Hello, so today we are going to do this problem, which is part of Leetcode Daily Challenge, least number of unique integers after k removals. So basically with this problem, we have an array of numbers and we have an integer k. And what we want to do is find the least number of unique integers after removing exactly k elements. So what does this mean? So basically we need to remove k integers, but we need to remove them in a way that we minimize the number of unique integers we are left with. So what that means basically is to have a higher chance of removing as many unique ones as possible, we should remove the ones with the least number of occurrences, right? So for example here, in this example, we can remove the least occurrence, which is 4. We are left with just one unique one because k is equal to just 1. In this second example, well, which one is the least occurrence? 2. And so now we have k equal to 2. And so we remove, let's say, which one we should remove? We should probably remove 4 because it just occurs once, so that we get the number of uniques down by 1. And so now we have 1. Which one we should remove? Doesn't really matter because whichever we remove, we still have one of it. But let's remove 1. So once we remove 1, we have 3 and 1 remaining, so we have 2. So that's the idea. The array length can be up to 10 to the power of 5. So this should tell us that we can do an open squared solution. But how do we tackle this? Well, what I said in the example, which is it's actually better. It's better for us to remove the least occurrence, the number with the least number of occurrence. First, why is that? Because let's say you have maybe you have 4 times, and then you have 2 times, and let's say you have 2 1 time. Okay, this is just the number of occurrences. And let's say k equal to maybe, let's try different values of k. Let's k equal to 2. Well, if you decide to remove if we do the contrary, if we decide to move the 4s, let's say 2 4s, we are left with 4 2 times, but the number of uniques is still the same. It's still 1 2 3. So we still have 3, but there is actually a better move. A better move is to remove the 2. So now we have 2 0 times. So this becomes, the number of uniques becomes 2. We can decide to remove either from 3 or 4. Let's say from 3, it's still 1. But let's take another example. Let's say, what if 3 was k equal to 3? Now in this case, if you decide to remove maybe 2 from 3, so it's 0, and then 1 from 4. Now we have k equal to 0. How many uniques you have? You have 2. But a better strategy, if we try it here, a better strategy would have been to remove this one, the 2, and then remove the 2 of the 3s. So now you actually have only 1 unique, right? So we already demonstrated that it's always better to remove first the least occurrence, the number with the least occurrence. So this is the greedy approach we can actually take. So let's just implement it. So what do we need? We need to know the number of occurrences for each number. In Python, you can use counter. If you are in another language, you can use a hash map. And what do we need to do? We need to get the least number of occurrences. In Python, you could get the most occurrence, the ones with the most number of occurrences, with most common. But if we get them in the order of the most number of occurrences, we can just reverse it to get the least number of occurrences. And so this will give us the number and the count of occurrence of that number. We want to remove the least number first, so this would be in the order of the least number. And so what do we need to remove? We are trying to remove k. We can remove more than k. And so let's just get a number that is the minimum between k and the count of this specific number. We can't remove more than, let's say, for example, we are at 2, it's 1 time, and k equal to 3. we can't remove 3 because there is only 1, 2. So we take the minimum. If let's say this was 4 and this was 3, we can remove only up to 3. We can't remove 2, right? We can remove all 4, right? So that's the idea behind this. And so once we so this is what we will remove. And so we say the occurrence of num was subtracted by what we removed. And then k also need to be subtracted by what we removed. Once k is equal to 0, we should stop. So break. Okay? Now what should we return? Well, we need to return basically the number, okay, of numbers remaining that have count bigger than 0. Because all those that we removed, the count became 0. So how do we do that? Well, we can just return so first let's identify them. So we need to go through the occurrence values to get the count. And this count would be, let's call it count, bigger than 0 for count in this. So this is the condition we need. Now what do we need? We need to know just how many. And so we can just take the sum of this. Because this boolean would be converted to 1 if you do a sum. If it's true, it will be converted to 1. If it's false, it would be 0. So we'll get the total number of the occurrence count values that are bigger than 0. And so this should be it. Let's run it. Let's submit. And it does pass, okay? Now in terms of time complexity, this most common here is overlagen because it sorts. We reverse, so overlagen plus oven, it's overlagen. So overall, this solution is overlagen time. And in terms of space, we are using this occurrence here, so which is oven, and so oven lagen time and oven space. Okay, so another way to think about doing this, if you didn't want to use this most common, maybe use the map here, and so you don't, or not, you are not using Python. How would you do that? Well, you could just get the sorted. You could just sort the occurrences, and so now, what do we need to sort? We need to sort the items of the occurrences, which are basically the number and the count. But what should we sort them by? Well, we need to sort them by the count, definitely. We need the ones with the smaller count first, and then the num can be after that, okay? And let's call this maybe A, and we can here just go through A. Okay, so this would be actually the reverse, the count, and then the number. This should work the same way. Looks good. Let's submit. Okay, still overlagen time because of this sorting, and oven space. Now I want to show a different solution here. So one way we can think about this also, if you take a look here, what are we doing? We are just taking the smallest first. We are just popping the smallest occurrence first. So what's good for popping the smallest value? A heap queue, a min heap. So let's actually just use a min heap here. So how do we do that? We can just have a heap that is going to be the values of the occurrences. Okay, so that we can pop the smallest one first. We don't care about the number. We only care about the how many we can get down to 0. And so here, what we can do instead, we of course need to heapify it as well to make it a min heap. And so while we have elements, actually while k is bigger than 0, because we know k is smaller than the length of the array, right? So we can just keep going until k is equal to 0. Can remove this. Now what should we remove? Well, we should just remove the smallest element, and the way to get the smallest element is heap pop. Okay, and we don't need all of this. Now how should we return what should we return? Well, we will remove, let's say for example in this case, our heap will have first 1 occurrence for 2, then we said 2 occurrences for 3, 4 occurrences for 4, right? So first we pop 1, and now k would be equal to 2. Then we will pop 2, now k is equal to 0. Okay, so we stop, but how many remaining we have left? Well, we have this 4, which is basically just the length of the heap. Let's say if you had even 5, maybe 5 times or something like that, then what you would have remaining is 5 and 5. And so that it's just the length. The length tells you how many elements, because this is the occurrence of the count of the occurrences of each element. And so we can just return the length of heap. Except there is one case where that's not the case. And that case is, what if, let me actually do it like this. What if k is equal to 2, for example? Now in that case, well, first our heap would have 1, 2, 4, 5 for the occurrences here. Now we first remove this one, so now we have k equal to 1. Then if we remove this 2, now k is equal to -1. Okay, because we can remove only 1 out of this. So if k is negative, that means the last one we actually weren't able to remove all the occurrences of the last one. So we should count the last one. So what this tells us is we need to add 1 if k is smaller than 0, because that means for the last occurrence we weren't able to remove all of them. We were able to remove only some of them. So 1 if k less than 0, else 0, right? We can run this, and that looks good. But we can also simplify this, because as I said, a Boolean condition, if it's true, it would be 1. If it's false, it would be 0. So we can just do it like this. And run this. If we submit, it passes, okay? Now, in terms of time complexity, still this is O of n to do this, O of n log n to do the heap, and the pub is O of 1, so O of n log n overall. Space is still O of n as well. But I think this one is a little bit easier to write. Yeah, so that's pretty much it for this problem. I hope this was helpful. Thanks for watching, and see you in the next one. Bye.